Hello, everybody. Welcome to section G-2 in our brand new unit in ESAC's geometry class. We're going to talk about parallelograms today. I've got a bunch of theorems I want to kind of go through, and then we'll have other videos for some of the examples because this will take a little bit of time. Anyway, a parallelogram is a quadrilateral, four sides. So any quadrilateral always has four sides. So a parallelogram, though, is a special quadrilateral. It's one in which both pairs of opposite sides are parallel. And you pretty much knew that. Parallelogram, opposite sides are parallel. But there are a lot of other properties of parallelograms that you may not know. And so now this is where you'll learn these. So we have I have 5 theorems written on this piece of paper as we work our way through them. So the first one is this. If a quadrilateral is a parallelogram, so in other words, if we start off with a parallelogram, then its opposite sides are congruent. So if you know this is a parallelogram, then you know that the opposite sides are congruent. Okay, so that's got to be true. And that's going to be helpful. So not only are the opposite sides parallel, the opposite sides are each congruent. Second theorem, if the quadrilateral is a parallelogram, then its consecutive angles are supplementary. Consecutive angles are the ones that are sort of next to each other. So angle B and angle A, they would be supplementary. Angle B and angle C would be supplementary. In other words, they would add up to 180 degrees. So that's what we have written over here. So if we have a parallelogram, then angle A plus angle B would equal 180. Angle B plus angle C would be 180. Angle C plus angle D would be 180. And angle D plus angle A would be 180. They're all supplementary. Okay? That makes sense as well. So we have opposite sides that are congruent and consecutive angles are supplementary. All right? What's going to happen with the opposite angles? What about B and D? What about A and C? That's what's next. If the quadrilateral is a parallelogram, then the opposite angles are congruent. So now we look, there's a parallelogram. So angle A and angle C will be congruent. Angle B and angle D will be congruent. Okay, we've got two more theorems to go through. If the quadrilateral is a parallelogram, then its diagonals bisect each other. That's an important one. So if we have a parallelogram here, then look at the diagonals. They intersect right in the middle there, but they are bisecting. That's sort of the midpoint of both diagonals. And that becomes a pretty important topic. That'll pop up in a proof as well, or probably not a proof, but some kind of a problem. The last theorem actually does not involve parallelograms. It involves parallel lines. So if 3 or more parallel lines are cut off congruent segments, so I've got parallel lines here, and I'm cutting them through with congruent segments here, then they cut off congruent segments on every other transversal. So if I know that AC and CE are congruent, then I know that BD and DF are congruent. Now, they're not the same measure as these two, but they are congruent to each other. So that's the same case over here. So if I know that we have CE congruent, then I'm going to get DB and DF also congruent. And so there's a quick look at the 4 properties. Let's run through them one more time so that we understand. Not only is a parallelogram got parallel sides that are opposite, which would be the definition of a parallelogram, but the sides opposite are congruent. Also, the consecutive angles are supplementary. The opposite angles are congruent. And the diagonals bisect each other. Those are all properties of parallelograms. And then this last one, if we have 3 or more parallel lines, and if we cut through them so that we have congruent segments here, then also any other transversal that cuts through will also have congruent segments. And there's a look at our notes. This is section G2.